we will work through the practice test then. Okay. Number one, I've got a copy of it if we need it. Number one just says rewrite the radical expression using exponents. Well, no, that's actually 3. Okay. So this one's not asking for us to figure out like a number answer, it's just wanting us to rewrite this thing. So instead of being as a radical, we want it written as a fraction exponent. So the thing to remember there is that this number out here, let me fix my pen there. This number out here is going to be our denominator in our new exponent. So the thing that's underneath the radical we just keep, but then it turns into a fraction with a denominator of 3. 2, 3. That's it on that one. It just wants us to rewrite. Questions on that one? Found it. Number 2 says simplify the expression. This one gives us the 5th root, 32y to the 6th on 9. It says simplify. So what we're looking for if there's anything that we can move out in front of the radical. So you can just look for perfect squares if you want to do that. If you see that 32 is 2 times 16. Oh, we don't have to do that. Yeah, okay, thank you. Okay, well, it's not a square root. I was thinking square root, so we're not looking for perfect squares. So what we're looking for is we're looking for 5 of something. Okay, so if we have 5 copies of a factor, then we can bring one out of the radical. So let me get that out of the way. What I would do on this one is I would do the little factor tree for the number part. Okay, so 32, that's 2 times 16. That's 2 times 8, 2 times 4, 2 times 2. So there we have 1, 2, 3, 4, 5 2's. Okay, 2 times 2 times 2 times 2 times 2. If you wanted to write it like that, we could say 32. We could write that as 2 to the 5th power. And then the variables are easier. We're trying to see if we can get a group of 5 y's, or y to the 5th. So we can do that. We can just rewrite y to the 6th as y to the 5th times y. So then because we've got 5 factors of 2, we can bring one out front. And because we've got 5 factors of y, we can bring one of those out front. So we end up with a 2 and a y out front. And then we have 1 y left underneath there. Questions on any part of that one? Yes. The 2, like y here, right here, why there are 2 y's? I'm trying to find this many. So I just turned that into a group of 5, and then I had 1 left over because there were 6. Yeah. Okay, several ways you can think about that, though. Okay. All right, other questions on that one? On those, we're just whatever the index is. Whatever the index is, you got to have that many of some factor in order to bring 1 out front. All right, let's see. Number 3 tells us to factor out the greatest common factor. And gives us 6x squared y minus 2x y squared plus 9xy. Okay. We're just looking to see if we have anything in common with all of these. If we're looking at just the coefficient part, just the number part, I don't see anything in common among all 3. And we've got a 2 in common with the first 2, but not the last one. We've got a 3 in common with the first and the third, but not the middle one. So we don't have a coefficient, but what do we have in common? A y. We have a y. Okay. And that's it. Okay, so if we factor that out, that leaves us with 6x squared minus 2xy. We took 1, we're left with 1, and then plus 9. Okay. That's it on that one. That's the answer. I just said factor out the greatest common factor, so that's all we had in common. Well, I said common factor, but yeah, we usually want the biggest one, so yeah. Okay. No questions on that one? Yeah, it'd be similar. Yep. Yeah, so these first few are some out of the review stuff we did at the beginning, out of the P sections. Okay. Number 4 is factor the trinomial, and the one I got was x squared plus 3x plus 2. It tells us to factor. So since it's a trinomial, that's the one where we have 2 cases. Either our leading coefficient's a 1, and that's the easier case, or it's not a 1. We have to work a little harder. On this one, our leading coefficient's a 1, so all we need to look for is we need factors of 2, or less number, that add together and give us 3. There's not a lot of choices of factors of 2. We only have 1 times 2. Okay, so that makes that part pretty easy. We need a 1 and a 2. They're both positive. And then to get the x squared part, we need x. I kind of squished that writing in. Okay. That's it on that one. Numbers could be a little bit trickier, right? You could have, like, instead of plus 2, you could have something with a few more factors, right, that you have to check. Questions on that one? All right. And number 5. Same thing, says factor the trinomial, but it gives us one where our leading coefficient is not a 1. Okay. So on these, remember we're going to take the first term and the last term and multiply them together. Here we get negative 14x squared. And that's what we want to find factors of. So we want to find factors of negative 14x squared that will add together and give us the middle number, negative 5x. So factors of 14, got 1 and 14, 2 and 7. And since it's a negative 14, we know one of our factors needs to be negative. That helps us. So which ones are going to work? Yeah, 2 and negative 7. And they're going to both have an x with them. Okay, so 2 and negative 7 will work. So here's where the way I do it might be a little different from the way you do it. That's okay. These are the ones where I take our two factors we found and rewrite the middle. So instead of minus 5x, I'm going to write plus 2x minus 7x. And then factor by grouping. That's what I'm going to do. You don't necessarily have to do it this way. So in the first group, I have a 2x in common. Leaves me with x plus 1. I know that I want my second set of parentheses to end up looking like x plus 1. So I see my signs are backward. And I have a 7 in common, so I want to factor out a negative 7 because we want to change the signs and we want to get rid of that 7. So, and that leaves me with x plus 1. And then it's the stuff in the parentheses. Factor that out, and that leaves us with the stuff that was outside the parentheses, 2x minus 7. Questions on that one? Again, you don't have to do that exact technique. If you have another method for factoring these trinomials like this, it's okay to do it that way. You can guess and check if you want to. You can do a box. You can do whatever you're comfortable with. Okay. All right, number 6 then. Let's see, number 6 says find the sum, difference, or product, and mine gives me 4 minus 6x minus 11 plus 5x. So on this one, we're subtracting. So if it's addition, you just combine like terms. On this one, since it's subtraction, there's only one other thing we have to remember before we combine like terms. The minus sign in between, it's probably best if we distribute that, okay, before we think about combining like terms. So I'm going to distribute the minus sign. We don't have to have these parentheses on the first one. So that'll be minus 11 minus 5x. And I've got two x terms. Negative 6x minus 5x gives me a negative 11x. And I've got 4 minus 11, that's negative 7. Okay. And on that one, remember if you're subtracting, you have to deal with the signs. Okay. All right. Number 7, if you do have any questions, make sure to stop me. Okay? Let me know. 7 says multiply using the FOIL method. And mine gives me 7t, which I don't really like when they use t as a variable, but 7t minus 4 times 3t minus 2. I don't really like t's because sometimes they look like pluses. Okay, let me take a look. Let's see.
I was able to do the first one, but that I tried just like no.
I don't know. You might have to log out and log back in and see if it'll
And here,
Mm-hmm.
that's the problem. I can't change this anymore. I had the problem. I had it like this one.
Okay.
I had this up to, I think, 40%. I did this too. Then I did them again. I couldn't manage it. But these two, I think I have it tried like 10 times.
Okay.
And I can't these answers anymore. Is there any possibility to do this?
Yes, there should be.
Because like this, and I can't do any.
Right.
Just
There should be somewhere on there. There should be something that says request submissions. Maybe it's at the top.
Request.
Yeah. Because if you run out of attempts, that may be. But nice extension.
I don't need any.
Yeah. Get with me before we leave, and then we'll find it. Okay. I can't remember where that button's at, but we'll find it. Okay. So this one we're doing FOIL. Okay. So 7t times 3t, that's 21t squared. I do the outer term, 7t times -2 is -14t squared. Inner terms, -4 times 3t is -12t. And then the last term's -4 times -2 is +8. Oh, hang on. That one's not a square, sorry. It's a 14. I just got a little extra there. Because it was just 7t times -2. So then we've got like terms to combine in the middle. That's minus 26t. And that's all we have to do on that one. I think that's most of the stuff out of the review stuff we do. And we kind of get to the new stuff. Okay. At least chapter 1 stuff. Okay. Number 8 says find all real solutions by factoring. Gives me x squared minus 4x equals 12. That's the one I have on this one. So this one specifically says by factoring, so that's what we'll do here. If we're going to factor, we need to get everything all on one side. We need to equal 0 on one side. And so I'm going to subtract 12 from both sides. And then now we're down to just like the factoring problem we did earlier. We need factors of -12 to add together and give us -4. So we've got 1 and 12, those don't work. 2 and 6, since we want -12, we need one to be negative, so what about 2 and 6? We do +2 and -6. And then these are x and x. And then what do we do when we get to this step? Yeah, set them both equal to 0. That's right. So x plus 2 equals 0. X minus 6 equals 0. Get two solutions there. Subtract 2 from both sides. Subtract. And then add 6 to both sides. And our two solutions. Questions on that one? Okay. So there will be one like that where it says solve by factoring, and I want you to do it by factoring. Most of the quadratics on the test are to just say find the solutions, and you can do whatever method you want. Okay, you can do quadratic formula and all the rest of them if that's what you want to do. And if it says solve by factoring, solve by factoring. And number 9 just says find all real solutions. Got another quadratic. Okay. So this one, we could factor if we wanted to. Okay. This one will factor. And the way I'm checking is I'm just looking to see if I can find the factors that will work. Okay. If you don't want to factor it, or if you don't see that it will factor, it's okay to do quadratic formula. If you factor it, we'd do it just like the last one. This one I'll do quadratic formula. Okay. So we can review that. So here our A is 1, our B is 5, and our C is negative 50. And I will give you the quadratic formula on the formula sheet. Okay. So it says negative B, so the opposite of B, so minus 5 plus minus square root. And the formula is B squared, so 5 squared minus 4 times A, which is 1, times C, which is negative 50. And all of that is over 2A, so 2 times 1. Okay. And then we just simplify. So let's see. 5 squared is 25. Negative 4 times negative 50 is positive 200. And all that's over 2. And if you were here last time, we ran into this square root of 225 a bunch for some reason. That comes out even. Square root of 225 is 15. Okay, so we will have negative 5 plus or minus 15 over 2. We'll get 2 solutions if we take the plus sign. Negative 5 plus 15 is 10 over 2, which is 5. That's what we get when we use the plus sign. If we take the minus sign, we'll have negative 5 minus 15 is negative 20 divided by 2, negative 10. That's what we get when we use the minus. Questions on that one? Okay. Hanging in there so far? Feeling okay about it so far? All right. Got another one on here that says find all real solutions, and it doesn't tell us how we have to do it. So I'm guessing maybe this one we get a different type of solution here. This one I have x squared minus 6x plus 1 equals 0. Yeah, we're going to get a different type of solution here. This one will not factor because we would be looking for factors of 1 that give us negative 6. Factors of 1 are just 1 and 1. So this one won't factor. So you could complete the square if you wanted to. Or I'm guessing most of you will probably do quadratic formula. So got A of 1, B is negative 6, C is 1. So we have the opposite of B, so positive 6, plus or minus square root of B squared. Be careful with the sign here. If you're putting it in the calculator, you need parentheses around that, since it's a negative number when you square it. Okay, and then minus 4 times A times C. That part's a little easier, at least. All over 2A. Okay, so then when we simplify, negative 6 squared is 36. And then we have minus 4 over 2. So we got 6 plus or minus square root of 32 over 2. And we just want to simplify. So one thing we could do, you could do a factor tree with 32. Or on this one, if you see it 16 times 2, that's okay. If you go to do the factor tree and then you see that and you see 16 is a perfect square, it's fine. Stop there. Want to. And because the square root of 16 is 4. You can take it all the way down and you'll get 4 2's over here. So every time you have 2 2's, you can bring a 2 out. So we'll end up bringing 2 of those out and get 4. But either way is okay here. So we'll end up with 6 plus or minus 4 square root of 2 over 2. And then we can still simplify some. 2 ways to go about it. Either you can see in the top we have a common factor of 2. Okay, 2 will go into 6 and 2 will go into 4. You can factor that out. And then cancel it with the 1 on the bottom. Or what may be easier, you can do it either way, but what may be easier is to split it into 2 fractions. So we'll get 6 over 2 plus minus 4 square root of 2 over 2. Maybe it's a little easier to see how to cancel there. 6 over 2 is 3. And then 4 over 2 is 2. Questions on any part of that one, on simplification or anything? That's the answer. We get 2, right? We got 3 plus 2 square root of 2 and 3 minus 2 square root of 2. Yeah. If you needed a decimal to do something with it, like maybe we're making a graph or something, then you could put it in the calculator and get a decimal estimate, but that's like our exact answer there. So really better. Questions on that one? Nothing? Okay. What was it, 10? Number 11, we get some i's. We deal with some complex numbers. Number 11 says evaluate the difference. Write our answer in a plus bi form. Gives us negative 9 plus I minus 2 minus 9i. Remember, on these we can just treat the I just like a variable. We can treat it like an x. Okay, so if we think about it that way, we've already done one really similar to this. Right? The only thing we have to be careful of on this one is the signs here. So I'm going to distribute this minus sign. That'll be negative 9 plus I minus 2 plus 9i. Okay. And then we just combine like terms. Since I know I'm going to put it in a plus bi form at the end, I'm going to do my constant terms, the numbers without the i's first. Negative 9 minus 2, negative 11. Then we have I plus 9i, so plus 10i. We're finished. Questions on that one? Adding and subtracting the complex numbers, not that complicated. We don't have to worry about getting I squared when we're adding or subtracting, so not all that involved. 12 gives me 2 complex numbers and says evaluate the product. Write our answer in a plus bi form. So we're multiplying this time. One common mistake I see sometimes is people overlook like the difference between number 11 and number 12 if you're not reading the directions carefully or looking at the notation carefully. This one's subtraction because it has a minus sign between them. And then number 12 is multiplication because there's not a sign in between them, right? They're just right next to each other. One common mistake I'll see sometimes is, oops, sorry, I don't know why I'm jumping around like that. Like people won't notice the minus sign and they'll just start multiplying before they really think about what they're doing. 11, so just watch out for that. Make sure you know whether you're supposed to be multiplying or adding or subtracting. Okay. So how do we multiply these two? What do we use? Yeah, we can use FOIL. Use FOIL. So I'll do 9 times 1 is 9. 9 times I is 9I. Negative 7 times 1 is negative 7I. And then the last term is negative 7I times I is negative 7I squared. So two things we have to do to simplify. We've got like terms to combine. And this I squared term, what's it equal? That's negative 1. Okay? So we can't leave I squared in our answer. Okay, so for the I terms in the middle, we've got 9I minus 7I is 2I. And then we had 9 and minus 7, but we multiplied it by negative 1, so we got 9 plus 7. So we end up with 16 there. And since we're putting in A plus BI form, I just went ahead and wrote it down that way. If you get 2I plus 16, you just switch it. On that one. Having questions? Okay. 13. We're dividing or finding the quotient of two complex numbers. So 13. Mine's one of the slightly more complicated ones. Got 6 minus I over 9 plus 6I. So when we're dividing complex numbers, we're really going to multiply by something over itself, right? What do we multiply by on this one? 9 minus 6I, yeah. So the conjugate is what it's called, but you don't have to necessarily remember that. Okay. Multiply by the conjugate over itself. And this one's a little more involved than some of the ones we did, but because on the top, we have FOIL method to do. So on the top, if we do 6 times 9, we get 54. If we do 6 times negative 6I, we get negative 36I. The inner terms, we do negative I times 9, we get negative 9I. And the last terms, negative I times negative 6I, we get positive 6I squared. So I'm just going to leave that right there for right now, but I'm making a mental note that we can't leave that I squared. On the bottom, where we're multiplying the conjugates, we've got two choices. Either you can remember the pattern. So here our A would be 9, our B would be 6. Or you can just use FOIL method again. Okay. So it works out the same way. Okay, so I'm going to assume you didn't remember the pattern on this one and do FOIL again. 9 times 9 is 81. 9 times negative 6i is negative 54i. 6i times 9 is positive 54i. And then 6i times negative 6i is negative 6i squared. Okay, so now it's time to start cleaning this up. I'm going to combine these middle terms on the bottom. The middle terms cancel out. So on the top, got 54 minus 45i and plus 6i squared. On the bottom, got 81 minus 6i squared. I'm sorry, which part? Did I mess something up? Yeah, it should be 36. Thank you. You're right. Yeah, 30, because 6i times negative 6i, negative 36. Sorry about that. Thanks for catching it. Okay. And then we've got a couple of I squareds to deal with here. Okay, so if we deal with those, plus 6 turns into negative 6. On the bottom, negative 36 turns into plus 36. So then we've got 54 minus 6 is 48 minus 45i over, goodness, on the bottom, 81 plus 36, get 117. And I don't think we have anything that cancels, but it did say put it in a plus bi form, so we need to split it into two fractions. So at 48 over 117, I just got unlucky and got kind of bad numbers on mine. Minus 45 over 117. So probably will not have numbers that ugly on the test. I try to make them like as small as I can. Trying to test your algebra skills, not your arithmetic skills. So. Questions on that one? That one, the simplification was just a little long, but something on that one? Okay. One more I problem here. 14, we're simplifying a power of I. The one I got was I to the 1,802 power. Okay, so my strategy on these, I try to rewrite it as I squared to some power. The way I do that, this one was even, so 2 will go into it evenly. Okay. So divide 1802 by 2, get 901. I squared is negative 1. And then if we are raising negative 1 to an odd power, we end up with negative 1. And there's 4 ways those can turn out. You either get 1, negative 1, I, or negative I. Okay. Questions on that one? Kind of quiet today. All right. Okay. 15. got one of those other types of equations that says find all real solutions. Gives us 8x to the 5th minus 72x equals 0. So if you have some exponent bigger than 2, that's a good clue that we want to factor out a common factor. And we really don't have other methods to use. Okay, so here, what do we have in common? Yeah, 8 does go in, okay, and if you didn't see that, it'll work itself out, okay, but then what else? An x, yeah. Yeah, if you just took out the x, it'll end up working itself out, okay? But getting the x out's the important part. Okay, and then that leaves us with x to the 4th, okay, minus 9. So here, if you got a couple options here, okay? You could see that this will factor again. This is the difference of two squares. If you don't see that, it's okay. Okay, so I'm gonna work it like we didn't see that. And if you did see it, you can factor it again. But if not, what do? Here we can split it into two equations. 8x equals 0. Divide both sides by 8, we get x equals 0. For the other one, x to the 4th minus 9 equals 0. So we can add 9 to both sides. And I don't know that we've done one exactly like this together, but how can we get rid of x to the 4th power? We can take if it was x squared, we could take the square root. Since it's x to the 4th, we can take the 4th root, right? Which is, you can do that on a calculator. But we don't have to, okay? We'd take the 4th root of both sides here. Let me scoot this over. So, since it's an even index, just like square root, we need plus or minus. If you take the 4th root, 6th root, 8th root, any even radical, we need plus minus. So on the left, we get x. And then on the right, there's nothing we can, this one's just ugly. There's nothing we can do there that won't simplify. So, and I got ugly numbers on mine. Okay. Questions on that one? The 4th root bother anybody? Okay. All right. Yeah. Yeah, so if you're putting it back in to check, you can just type it when you go back to the original equation. Where you put it in the x, you can just put in 4th root of 9 in your calculator and it'll check out. It probably won't have one that ugly when I'm picking the problems on purpose. Okay. So if I was making this problem for a test, I would have made this come out to like 4th root of 16, which is 2, then it's easier. So you'd have plus minus 2. Other questions on that one? Okay, 16. Let's find all real solutions. It gives us a rational equation. So we have z plus 64 over z plus 4 equals 12. So the method I showed you in class for these is that we multiply through by the least common denominator, multiply every term by that. since we only have one denominator, that is our least common denominator. Okay, so our LCD here is z plus 4. Okay, so that's what we're going to multiply everything by, because that gets rid of the fractions. Okay, so if we do that, we have z times z plus 4 plus 64 over z plus 4 times z plus 4, and that equals 12 times z plus 4. Okay. The reason why we do that is because these cancel. So then with that first term, we've got distributive property to do. Okay, so z times z, z squared. Z times 4 is 4z. And then the second term, we're left with just 64. On the right side, we've got distributive property, so it's 12z plus 48. And since this thing is quadratic, and I'm going to get everything all on one side and then probably use quadratic formula, unless it just looks like it will factor easy. The numbers are kind of big, so I'm guessing we'll probably do quadratic formula here. So if we subtract 12z from both sides, we get 4 minus 12, we'll get negative 8z. And then if we subtract 48 from both sides, 64 minus 48, we get 16. Oh, so that's not that bad. You could do quadratic formula if you wanted to, since that's not too bad. I'm going to go ahead and factor. Because we need factors of 16, that would give us negative 8. So we got 1 and 16, that won't work. 2 and 8, that won't work. But if we can do 4 and 4, and we need it to give us negative 8, so we can do negative 4 and negative 4, that'll work. So I'm going to factor here. We'll have z minus 4, z minus 4. And then we set both of these equal to 0. We really don't have to do 1 since they're the same. Get z equals 4, but we need to check this, because sometimes when we multiply through by the LCD, we get those solutions that don't really work. Okay, so what I'm going to check is to make sure it's not going to make my original equation undefined. We had positive 4. So if we plug in positive 4 right here, we're okay, because in the bottom we get 8. If we had ended up with negative 4, then it would not be a solution, right? Because we would get 0 on the bottom here. And this one's okay. So this one checks out. Questions on that one? That one's a little longer. Good with it? Okay. 17. We're getting close to the end. There's only 19 on here. To start with, one of my problems didn't save on there. So maybe if you looked at the practice test early, you only saw 18. But I guess I forgot to hit the save button when I was adding a problem there. So there is one more. There's 19. Okay. 17. Let's find all real solutions. Square root of 8x minus 1 equals 9. Okay. So on this one, we want to get rid of the radicals, what we're trying to do. So we need to make sure it's by itself on one side. It already is on this one. And so then to get rid of a square root, what do? Square, yeah, so we're going to square both sides. So raise both sides to the second power. On the left, the square and the square root cancel out. We just get 8x minus 1. On the right side, 9 times 9 is 81. I'm going to add 1 to both sides. Divide both sides by 8. So x is, we just need to see if there's any factors we can cancel out. I know they're both even. So that'd be 41 over 4, and that might be as, yeah, that's as far as that one will go. So get a fraction, that's okay. On these also, we need to check because when we want to make sure that when we plug it in, we don't get a negative underneath the radical, because that could potentially happen. So what you can do on this one, since it's a fraction, you can just do 41 divided by 4 and see, get close to it, and you'll probably have an idea. So that's 10.25. So this is going to be 80 something minus 1. That's going to stay positive because the positive 80 something is a lot bigger. So that one's okay. So that one checks out. Questions on that one? Okay. 2 more. 18. Says solve the linear inequality, and then we gotta do our number line and our interval notation to show the solution. So mine is 9 minus 3x less than or equal to 7 minus 9x. Okay. To me, it's a lot less confusing if we get the x's over to the left side and everything else over to the right side. So I'm going to add 9x to both sides. So I have 9 plus 6x less than or equal to 7. And I'll subtract 9 from both sides. Give me 6x is less than or equal to negative 2. Divide both sides by 6. That's a positive number, so we don't have to worry about flipping the inequality. So we get x is less than or equal to negative 1/3. Okay. And for the number line, since we have the or equal to bar on there, we're going to have a closed circle at negative 1/3. Solid circle, whatever you want to call it. And then since we want the values less than that, we're going to shade to the left. So shade over here. And for interval notation, start off thinking about what's the smallest my solution can be. It goes forever to the left. So where do we start out? If it goes forever to the left side. Yeah, and it's on the negative side, so negative infinity. The infinities always have a parenthesis. And then, so if we start off negative infinity, how big can we end up getting? we got to stop when we get to -1/3, right? And then since we've got or equal to, we've got a closed circle, then with -1/3, we'll have a square bracket because we're including -1/3. Or interval notation. Questions on that one, on the interval notation part or anything? It's on paper. Yeah, it's on paper. Yeah. Yeah. Nah, I'll just give you a little number line. You can just do it like I've been doing it on screen. So. Yep. Okay. Anything else? Okay, one more. 19. It says find the equation of the circle that satisfies the given conditions, and this one says that the center of our circle is at -8, -9, and the radius is 7. Okay. So we're just plugging into the standard form of a circle. That standard form of a circle will be the other thing on the formula sheet. So the formula sheet will have quadratic formula, standard form of a circle. So you'll have this on the formula sheet. So that should make this problem pretty easy. Okay, we're just had to be careful with the signs. Okay, whatever the center is, when you put it with x, the sign's gonna flip because it's subtracted. And so we'll have x plus 8 squared plus y plus 9 squared, and then over here we'll have 7 squared, which is 49. That's all I need. Questions? All right, so this is recorded if you need to go back and see it. Let me stop that actually.